The years unknown, 1601, 1607, who knows when Pierre de Fermat's birthday is, but it's assumed to be within these years. He was a famous mathematician born in Beaumont-de-Lomagne in southern France. While his half-brother died in infancy, his mother died when Pierre was 7. Due to his family's wealthy status, he received an excellent education, became fluent in 6 languages, and was able to attend a university and graduate when he was only 18. Soon after, Pierre de Fermat attended the University of Orleans, where he learned his degree in civil law, allowing him to pursue a career as a lawyer. Around age 19, he moved to Bordeaux, France, where he became an attorney in the High Court. Then, around 1630, he was sworn into one of the high courts of judication in France, married the 4th cousin of his mother, and had 8 children. Additionally, around this time, he began to take his mathematical research seriously. Although high-level mathematics was his hobby and not his profession, he still made many significant contributions to the field of mathematics. He is known as the founder of the modern theory of numbers, the inventor of differential calculus, and he is famous for discovering the fundamental principle of analytic geometry. Even though Fermat never published his works, historians know that these contributions by studying his frequent correspondence with other mathematicians.
Hello everyone, my name is Pierre de Fermat. Put your hands together if you're excited to learn about Fermat's theorem of stationary points. Thank you very much. First, let's go over some background information. The first piece of background information is that local extrema are the largest and smallest values within a given range. Next up is stationary points. Stationary points are any points where the function's derivative is 0 and where the function is differentiable. Therefore, the tangents of these points are horizontal. And the last piece of background information is the derivative by first principle. And what this states is that the derivative of f is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is the more precise definition of my theorem of stationary points. In simpler terms, this states that if a function has a local extremum at a differential point, then the function's derivative at that point is 0. Here's how I got to that conclusion. So first, let's assume that there is a function that is differentiable at c and has a local maximum at c. Since there is a local maximum at c, for all the x values near c, f of x minus f of c will be less than or equal to 0. And for the x values that are close to c but to the left of c, c minus x will be greater than 0. Therefore, f of c minus f of x divided by c minus x will be greater than or equal to 0. And you can use this to say that the limit as x approaches c from the negative side of f of x minus f of c divided by x minus c will be greater than or equal to 0. So we can repeat that process for the right side of the graph. So for x values that are close to c but greater than c, x minus c will be greater than or equal to 0. Therefore, f of x minus f of c divided by x minus c will be less than or equal to 0. And we can use that to say that the limit as x approaches c from the positive side of f of x minus f of c divided by x minus c is less than or equal to 0. So if we combine these two one-sided limits, we find that the limit as x approaches c of f of x minus f of c divided by x minus c is both greater than or equal to 0 and less than or equal to 0. So we use that to make our final conclusion, which is that the derivative of f is equal to 0. Hello everyone, I'm back, so make some noise if you want to go over an example problem. Thank you very much. So we're going to use Fermat's theorem to find the relative extreme values of the function f of x equals x squared minus 4x plus 9 in the interval 1, 4. So the first step to finding a function's extrema is by calculating the function's derivative, which I did over here, and you end up getting 2x minus 4. So since Fermat's theorem states that the local extremum at a differential point has a derivative of 0, we'll set the derivative of f equal to 0. And now I solve for x just by factoring out the 2 and dividing both sides by 2, and then adding 2 to both sides. So this means that 2 is a stationary point, but we still don't know if x equals 2 is where the relative max or min is located. Okay, so we know that x is equal to 2, so I set up this number line over here. So if you plug in a number that is less than 2, we find that the derivative is negative. And then if you plug in a number that is greater than 2, we find that the derivative is positive. So the change in slope from negative to positive around the stationary point of 2 shows that there is a relative minimum at x equals 2. Thank you very much.
At Castres in southern France, Pierre de Fermat died on January 12, 1665.